Hello there, my name's Steve. I'm the developer of Self-Loading Cargo. This is the development update for version 1.5, which is hopefully going to be released in early November. What the purpose of this video is to basically show you some progress on the application, one of the major features that I've been working on, and hopefully it will explain a few of the more common questions that I get about self-loading cargo, which is basically why things take a certain length of time and what actually happens behind the scenes on self-loading cargo. We'll get into it. So first thing I'm going to do is we're actually in X-plane at the moment. I'm in the Tullus. I'm going to start this flight. I'm going to set this to 40 passengers, which is quite a low number for what I'm going to demo to you, but it'll speed the process up. And if first thing I need to do is press start flight, it's going to ask me to turn on the aircraft power, so I will do that. Fuel pumps are already on. Let's align the navs. I'm not going to take off today. I'm just going to basically show you how the boarding process works and basically the simulation behind the application, because it's quite interesting, and the visual stuff I've done for this next release will hopefully explain a lot of what goes on and answer a few questions. So the purpose of self-loading cargo is to simulate the cabin of your aircraft, and that is the layout of the aircraft, the cabin crew on your aircraft, and the passengers who have chosen you to take them on holiday or to wherever it is that they want to go. It is not a pilot simulator, it is a passenger reaction simulator. So any grade that you get within self-loading cargo is based on how you've made the passengers feel. It's not how well you've flown the plane in terms of your rating as a pilot, it is how well you've flown the plane in the opinion of the passengers that you've got in the back. And it's an important distinction to make, because a lot of people are getting bogged down with like the landing rate, etc., whereas really what you should be focusing on was the landing comfortable from the point of view of the passengers. They won't know the exact rate, they won't know it was minus 144 feet per minute, they will just say that was a smooth landing or something like that. So it's that type of thing. What is happening in self-loading cargo is there's an actual simulation of the cabin crew and indeed the cabin behind the aircraft, and it's been quite hard to kind of explain what's been going on. What we have got here is I did build a cabin manifest so you could see the actual the people who are in the cabin. You'll notice that there are a lot of cabin crew on this plane, and there is a reason for that, which I'll get into in the moment. But you can see in here we have seat numbers for each of these passengers, but it still doesn't really show you the simulation that's going on behind the scenes. It does show you the ratings for the happiness, anxiety, boredom, hunger and thirst for each passenger, but it doesn't really go into any depth as to how those values are sort of arrived at for each passenger. So this works in terms of you can actually see the information about a specific passenger, and you can get the overall sort of gist of the feeling of the cabin, but you can't actually see what's happening within the cabin. What you can see here is obviously these people are not on board the plane, they're greyed out, they're on our manifest, they have been allocated a seat, which is actually new in version 1.5, but we've got cabin crew on board. However, we are in an A3, well, you can't see that because it's behind the window, but we're in an Airbus A319. We are not in an A380, and what we've actually loaded is the configuration file for an A380. What is the configuration file? Well, the configuration file allows you to define the layout of a particular aircraft in terms of the seating arrangement, the classifications of the seats, where the aisles are, basically where everything is in the back. That then allows your passengers to be in the correct position on the plane. It allows the cabin crew to walk around the plane in the correct locations, like aisles for instance, and it basically allows the simulation to happen in a timely manner, because if you start serving drinks, you don't want to do it accurately. Not every passenger on the plane would get served a drink at the same time. It would take time for the cabin crew to work their way down to the back of the plane and serve each passenger in turn, and that's exactly what SLC does, but it's not always kind of easy to explain to people without being able to see what's going on. So this kind of works, but it doesn't really give us any information about what's going on in the back. So how did we get around that? Well, as I said, this aircraft has loaded in an A380 configuration. I'm going to show you an example of the configuration files. So I'll bring up Visual Studio. I'll just transition into there for you. Now this particular one here is a 757 configuration file, and you'll notice that there are various, it's a delimited file, comma delimited file, and each sort of delimiter has it's hard to explain, but you know what I mean. It's quite late, sorry. Each one of these has a specific value, and it gives purpose to the coordinate within this grid of delimited values. So these X's here, they mean that there's a wall there. We can't use that spot in terms of the person walking around the plane. We have these dashes, which represent the aisles. We have a business class seat, which is seat 31J. We have a premium seat, which is 36H. We have economy class 39H. You get the gist. We've got, actually that one's wrong there, so I'll just change that. Missed that one out. It's backwards. So you can see how easy it is to kind of edit the seat numbers to be relevant. This allows you to have any type of configuration for any plane in any way you want. So if you want to have row numbers, I don't know, A to X, and skip out all the ones between G and P, you can do it if you like. You can rename it as you like. We have G for galley, which is where the crew members go. We have C for cockpit, and if I zoom out, you can basically see that the text file is giving us the basic layout of, in this case, a 757-200. So we've got many seats back here, we've got many seats in the middle. We have, if I zoom in, we have T here for a toilet. So you get the idea. We've got doors here. The doors are actually tied to the FSU IPC data refs. So if you open exit 1 will open from this configuration file. So you can place the doors wherever you like, and passengers will actually come through the doors. Anyway, we're getting a little bit ahead of ourselves. So this configuration file is for a 757-200. It's a single deck with a single aisle. So what if we had an A380 which has multiple decks? Well, we need a configuration file for an A380. Again, this is obviously we've defined our aisles, we've defined our seating, we've got business class up here, we've got a first class area, and this here is a second deck. Well, it's the first deck, and then we've got a second deck underneath it. If I zoom out, you can basically see the aisle definition and the deck definition for an A380. A lot more seats, a lot more ways for the cabin crew to find their way around the aircraft. So what does that give us? Well, what it gives us is, if I go back into explain, bear with me 2 seconds. Bear in mind we've loaded that A380 configuration file, and we had this manifest. Hopefully you remember what that text file looked like, but what it does is generates an actual grid of the layout of the aircraft, and here it is. So we've got our upper deck, we've got our lower deck. You can see the colour coordinations for the different classes. So we've got a first class here, we've got business class area here, we've got white premium seats, we have the green toilets, we have economy seats in grey, which make up the most of the lower deck. We have a cockpit area here in aqua. The pink are the walls where no one can walk. We've got orange stairwells because if a passenger needs to get from one deck to the other, they need to use the stairwell. So if they go onto this coordinate here, they will then pop up onto the associated one on the deck above. So they can travel from the exits of the aircraft to whichever deck they need. And the way it does it is, obviously, like I said, there's a simulation running behind the scenes in self-loading cargo to determine the best, most efficient route for a given person to get to a specific target on the grid, whether that be their seat, or from their seat to a toilet, or in the case of what I'm going to show you now, a cabin crew member to get to one of the doors. So you can see that we've actually got the cabin crew already loaded. So if I mouse over this person here, you can see this one person is called Chloe McIntyre. She's cabin crew. We've got someone sitting next to her called Yvonne Williams, who's also cabin crew, and they are in the galley seats which were defined in that configuration file. They're already on board, they're all sitting down. Now what's going to happen is, the first thing that we do in self-loading cargo is we have to open the door. And if I press this button here, one of these doors is going to open, and one of these cabin crew will go to the door to start greeting the passengers. If I open 2 or 3 doors, then 2 or 3 cabin crew will find their best route to get to any door that's open. Now, having said that, in this early version of the code, because there are a few errors, it's pre-production, it may not be the closest cabin crew member goes to the door that is open. It might be we open this door and one of these ones starts walking towards the exit. And also, there's another limitation at the moment. When I open door 1, it will open on both decks. That's something I'm still working on. Like I said, this is pre-production code, but I just want to give you an illustration of how the simulation works and where we're heading. So, if I open the door, let's turn on the music, because the passengers like that. If I open the door, you'll see this exit open. These ones are red, this one's open. And we've got a member of our cabin crew actually heading towards the door. How do we know where they're going to go? Well, we can click on them, and it will show us the route. It'll show us the information about that cabin crew member, and then the actions that we can use to perform. If we want to interact with the simulation is going to happen anyway, but we can sort of inject our little things into what's going on. So say if we wanted to move a passenger, we can click on them, select move, and then move them into a different position. That may come in handy if that particular passenger is drunk and annoying passengers around them. We can move them to an empty seat to stop the other passengers from getting annoyed. But that's sort of later down the line. So there's 2 cabin crew have left their seats and gone to the exits on each deck. If I close the doors, you'll see that they'll head back. They've already started heading back. This one's decided to stay where it is. In typical demo format, it's not going to work. But like I said, it's pre-production code, and there are a number of little issues. But you can see this person here is actually heading towards that empty seat there. So let them do their thing. Get back into the seat. And then we'll do it again. Now, if you're worried about frame rate, remember, if you've been using SLC so far, this has all been running in the background anyway. So this won't actually impact your frame rate whatsoever. This visualization might, but I'm on a laptop and I'm recording this video now while running X-Plane and SLC, and I'm only at 4% CPU. So it's not really that big an impact. If I close this window down, SLC goes down to about 0.4% CPU, and it's not the most powerful laptop, so it's quite efficient, and it works really well. And like I say, you can also close this window if you do find that it causes issues for processing. So what we're going to do now is I'm going to open the door again. We've got a cabin crew member going to the door. This one's already there. This one's going to move back. So you are at the door. Nadia Addison, female, 25. Her seat number is Galley 13, which is this seat here. Galley 13. So let's pretend that that cabin crew member has gotten there quicker than they have. Let's start letting on the passengers. You'll see them start appearing at the doors and walk into their seats. So here's one here. They're only circles because they don't have their belt on. Once they're belted up, they will fill, so you can see who is seated and belted. Whereabouts are you going? So he's going here. This person is Oliver Roll. He is 12 years old. He's by himself, and he is in the economy class. Seat number D72. If we mouse over there, we can see that that is seat number D72. We've got one here. They're going to this position here. We've got other people on the other deck who are using that entrance to get into their seats. So you can see they've all got targets defined. They all know where they're going, and they're basically going for it. They're just finding their own way there. And like I said, if this was a properly loaded aircraft, this would take some time. And hopefully you can see why it takes time to board. Because the passengers are... If it was a real plane, they have to walk down the aisles, which takes time. In this, the simulation is simulating the size of the plane, and it simulates the time that it takes for a person to walk down the aisles, to get into their row, to get themselves seated, and then put the belt on. You'll notice that the seated count at the top here only updates when they have actually reached their correct seat. So we've got 19 on board, but only 13 seated. So the simulation is working. Like I say, it has been working in the background all the way along, but hopefully now this kind of illustrates why things happen in a certain way. And on that note, it also explains why the drink service takes so long, or takes a certain length of time. Because when you think about it, the cabin crew members who are serving drinks have to traverse these aisles. They have to go from row to row to row to row, or aisle to aisle to aisle, and serve the number of passengers who are actually on that aisle as well, which each individual passenger takes a certain length of time. If you have many passengers, it takes longer to serve drinks. And it also means that if the drink service gets interrupted, for instance, if you start the approach phase and you're halfway through the drinks, the half of the plane that hasn't been served yet won't be happy. So that's why you get a negative rating, because the service stops, half of your passengers haven't been served, and their satisfaction rating goes down because they wanted a drink. So it's not just a case of pressing a button to serve drinks and having the whole plane be satisfied. It's done on an individual passenger basis, using the time it would take to actually physically serve them if you were walking around the plane. So we're trying to go for accuracy here. I'm trying to make this simulation of the cabin crew as accurate as possible based on the size and layout and number of passengers on the plane. And it's going quite well. So other things on this screen, obviously we've got a key so you can see exactly the layout of the aircraft. We have flight information, which will show the time that the plane was boarded, when it came off the blocks and started pushback, the amount of time it took to taxi, the takeoff time, the landed time, the taxi to the gate time, the time we came on blocks, the time that the plane was actually deboarded and any delays, and the total flight time, sort of boarded to deboarded, and that will go in your logs. And so there we go. It's ready for us to shut the doors, so we'll do that. See, they're not all seated, but they are all on board, so I can close the doors. The cabin crew hopefully will start going back to their seats. So this one's heading back. This one's stuck for some reason. Typical demonstration monkey, doesn't want to perform. But
good afternoon, ladies and gentlemen.
So now all the passengers are on board.
This is your captain speaking, and I'd like to welcome you aboard this flight
all of the passengers.
We're
they
not
can't hear the
anticipating any delay,
tannoy
so we hope
because
to
they're
be
on
up in
board.
the air in the next
They may
15
not
minutes or
necessarily
so.
be seated.
It looks like we're in
This
for a
one
nice
still
calm
doesn't see
departure
it,
where the wind
heading
is concerned,
towards
so it should be smooth flying all the way up to
there.
our cruising altitude.
Nicholas
You should get a nice view as we climb, so make sure you enjoy the view out of the windows. If you're not lucky enough to have a window seat, feel free to ask the person next to you what it looks like, and I'm sure they'll oblige. For now though, the ground crew are loading the last of the baggage into the aircraft, so if you could get yourself seated and secured in the meantime, we can make a departure as soon as they're finished. Thank you.
Again, they are kind of randomized based on their own individual parameters as to how long it takes them to put the belt on, how likely they are to put the belt on. If the plane starts moving, this guy might start putting his belt on. Everyone else has, but he's resisting at the moment. Put your belt on, dude. He's looking out of the window, according to his current status. No, he's not going to put his belt on. Another non-performing monkey, unfortunately. But you can see now what is going on with the simulation. I hope you like what you see. This is obviously something that I'm working on and hoping to get out for you in the next update. But I just wanted to clarify where the simulation is going. You will be able to click on individual passengers, like I said, and inject an action into the simulation if you so wish, or you can just watch or let the simulation run in the background if you just want to concentrate on flying the plane, obviously being a pilot. Or mix and match, watch it and inject your different actions. These actions will be dynamic based on what's currently happening on the plane, so if someone is being temperamental or they have a medical issue, then the actions that you can perform on them will change. Obviously it's in development. Hey, he's finally put his belt on, there we go. So this cabin crew is decided just to camp out at the front door. Miss Nadia Addison. I'm sure she'll take a seat once the plane starts to move. But for now, I'm going to leave it there. I hope you enjoyed this video. I hope you like what you see with self-loading cargo, and I hope you like the direction I'm taking it in, because it's something I'm quite proud to work on. It's quite an interesting problem. The kind of the mathematics behind this this path calculation has been a little bit of a headache, but we finally got it working, and looks pretty good. And I'm quite proud of the fact that it allows you to have any different configuration for any different plane. And it's going to open up basically different configurations for the same plane but with different liveries. So yeah, it's going to make SLC completely dynamic and allow you to have a different experience on every single flight, which is what you would experience in the real world, because we all know how temperamental passengers can be. So yes, thank you for watching, and look out for version 1.5, and you'll be able to play with this yourself when it releases. So speak to you shortly. Thank you.